I just started. Is that distracting, that blinking thing? Not too bad. Okay. Okay. All right, so lesson 1.1 is evaluate expressions and use exponents. Below that, I want you to write this vocabulary word. Okay, you guys ready? So that first paragraph, right on 1.1, it says, a variable is a letter used to represent one or more numbers. So the next vocabulary word is, what do you think? Oops. Yeah, that's right, algebraic expression. Good. Algebraic expression is numbers, variables, and operations. I think I gotta stop that blinking thing. It's distracting. It's distracting me, yeah. Is it distracting anybody else? No? Okay. All right, good. All right. Okay, so we have these two vocabulary words. The first one's variable. I think you guys are probably familiar with this, right? An X, good. Okay. So, good. Variable says a letter. So in math, you see a lot of numbers, but you're also going to see letters. Like, most commonly, the letter X. Okay? What this means is X is a letter used to represent one or more numbers. Okay? So this is pretty basic here at the beginning. When you see a letter like this, X, it represents a number. The problem, though, is we don't know necessarily what number it is. Okay? So one way to think about it is it's like a blank spot. An X is like a blank spot. It's like a blank, and you got to figure out what number is in that blank. Does that make sense? Okay. Algebraic expression is numbers, variables, and operations. Well, you guys know what numbers are, right?
Yeah.
1, 2, 3. -10, right? 1.6. Those are all numbers. You guys know what variables are? X, yeah, a letter, right? Used to represent a number. So what about this? Operation. Yeah, good. Okay, so under operation, yeah, there's a few operations. There's multiplication, division. Any other ones? Subtraction, addition. There's actually one more. And exponents. It's not that, okay, good. That's good. You're talking about the order of the operations, right? So that there's an order that you're supposed to do the operations in, which is called the order of operations, or PEMDAS. All this is saying is, what are the operations? I don't care like what order they're in, just what are they? Operations are things basically that you can do to numbers. You can add numbers together, you can subtract them, you can multiply them, you can divide them, or you can raise them to an exponent. Okay? Operations, like stuff you do to something. The doctor's going to operate on your body, You'd be like doing stuff to your body. Operations on numbers is when we're doing stuff to the numbers. Adding them, subtracting them, dividing them, multiplying them. Okay? So, any questions yet about what a variable is? No? What about what an operation is? No? Everyone's cool with this so far? Okay. Now, an algebraic expression is numbers, variables, and operations. Not necessarily all of them, but it could be all of them, all together. Okay? So, below this, let's copy down that little table. You see that green table there on the page? Yeah. Okay, so let's copy that. It says algebraic expression is one column. Meaning is the second column. And operation is the third column. So here are just like some examples. And the first one says 5 parenthesis n, 5 times n, and 5n. Okay? Now, these are actually 3 separate expressions, and they all mean the exact same thing. So sort of the point of this is for you to realize that all 3 of these mean 5 times n. So the meaning of this is 5 times n. And that you can write 5 times n in different ways. If you see a little dot in the middle, that means times. If you see no dot in the middle, just a 5 next to an n, that also means 5 times n. These two are the same. Or if you see this parenthesis next to the 5 with the n inside, that also means 5 times n. Now, this one's not in the book, but can anybody think of another way to write 5 times n besides those 3? Well, that would be 5 times x. How can you? Can you think of a fourth way to write 5 times n? You said 5 times x.
Yeah, no, change it.
N 5 times?
N 5 times? N times n times n times n times n, like this?
Yeah.
Okay, so that, you think that means 5 times n? That's n to the 5th power. That's not 5 times n, that's n times n times n times n times n. What's another way to write 5 times n? Okay, how about n times 5? Good one. Okay, so here you go. N times 5. Right? So when you're multiplying, the order of these doesn't really make a difference. 5 times n, n times 5 is the same thing, right? Just think about it like this. 3 times 2 is the same as 2 times 3. The parentheses wouldn't matter either, right? That's good. Like you're saying like this. Could I do this?
No, I meant n.
Put n in the parentheses?
Yeah.
Like this?
That matters, right?
Those are all the same. No, doesn't matter. Okay, like this? That's good. That doesn't mean 5 times n, though. That means n times n times n times n. 5 n's all multiplied together. Okay? 5 times n is the same as Savannah, are you the one that said n times n times n times n times n? Yeah? That's not 5 times n. But this is almost 5 times n. What could I do to this so this actually would be 5 times n? Yeah, change all these timeses into pluses. 5 times n means 5 n's. Not multiplied together, but added together. 5 times n is the same as this. questions yet? Okay. What's the operation that's going on all these? Up here? Multiplication. Good. So over here we're going to write multiply. Good. Okay. Next line. 14 over y. And then they also write it as 14 divided by y. Those are two different expressions that mean the exact same thing. What do those both mean?
Is 14 divided by y?
It's 14 divided by y, and it's division. Is the operation good? 14 divided by y. Put division over here. So the point of this little example is for you to realize that if you ever see a fraction, right, you guys sort of freak out when you see fractions. Some of you do. A fraction just means divide. Sort of comforting, I think. You know what dividing means. When you see a fraction, you could just rewrite it as a dividing question if you want. So 14 divided by y means 14 divided by y, or 14 over y. For example, what about this? 3 over 2 is the same as what? 3 divided by 2, yeah. Okay?
Or you could cancel them.
You could cancel them? What do you mean?
Like 2 and 3. Multiplying.
Oh, you want to multiply by the reciprocal. You could you could do that sometime. Okay. Okay. Moving on. Next row. What's the next one say? What's the next algebraic expression?
Plus c.
Good. 6 plus c. Okay. That's addition. Good.
Plus c.
Right? And what does that mean? That means 6 plus c. Good. Okay? So, this is an expression. It's got a number. This is a... Yeah, addition is what type of thing? It's an operation. Remember, like, look. Algebraic expressions are numbers, that's the 6. Variables, that's the c. And operations, that's the plus, right? So, numbers, variables, and operations, right? So 6 plus c. 6 is the... No, 6 isn't the variable.
Oh,
Number.
6 is the number. Plus is the...
Variable.
No. Plus is the operation. And c is the variable. Now what the c means, it's a variable, it just means it's a number that could be anything. This means 6 plus something. A blank. Could be 6 plus 2. Or 6 plus 10. We don't know what it is. Okay? So, this is an expression. 6 is the number. That's the operation. And the c is the...
Variable.
C is the variable. Okay? Any questions yet? Sure?
I'm missing this period.
All right, here we go. 8 and x. What does that mean?
8 minus x.
Good.
Is subtraction. Operation is subtraction. Minus sign subtract. No,
Okay. Good. This is an expression that means 8 minus x. The operation here, Alasia, is,
Minus.
yeah, or subtract. Okay, so, raise your hand if you tell me what part of
Number,
the...
operation, variable.
Yeah, that's right.
you feel smart.
8 is the
Number.
subtract is the operation, x is the
Variable.
variable. Any questions?
No.
Okay. Here we go. Moving along. You get it? All right. So we got those two words. We got variable and algebraic expression. And then we have this table, and then below that, right, evaluate an algebraic expression. What does that mean? So we know what an algebraic expression is now, right? It's those things that we just put in the table. 6 plus c, that's an algebraic expression. How do we do this thing called evaluate? What does that mean?
It means solve.
It means solve?
Yeah.
I don't know if it means, I mean, I guess you could sometime, you might want to say that. It's probably just read it in the book. It's probably,
You want us to go look in the back of the book? Go ahead.
you don't have to look in the back, it's on page 5. See, it's right below the table. See how we're doing this? Right? What is it? What is evaluate?
Break down step by step.
No. It means.
It does.
Look, all you got to do is read it. It says it right there. It means this. Substitute
Just read that bull since you in a different class.
You like you got one. You stop instigating.
Okay, evaluate an algebraic expression. An algebraic expression is going to have a variable in it, right? Like the c, the 6 plus c, the c. Evaluate means substitute. You guys know what substitute means?
Yes.
What?
To replace.
To replace, right? Like trade.
Yeah.
Like if you're on a soccer team, substitute, like one player comes out, another player goes in, right? Substitute basically means one thing comes out and something goes back in its place, right?
Yeah.
Substitute teacher, the regular teacher goes out, the substitute teacher comes in, right?
Yeah.
So evaluate an algebraic expression means substitute or trade a number, so we're putting in a number for each variable. The variables are the letters. So it's like when you 6 plus that one 6 plus c. It's taking the c out of the game and putting in its place a number, 5 or something, whatever they tell you to. Okay. So it's taking the letter out and replacing it with a number. Now that's just the first part. So substitute a number for each variable, then perform the operations. What does that mean? Perform the operations. Yeah, basically do the problem, like do the adding or the multiplying, whatever it is they ask you to do, and then simplify it, which is basically do all the operations. Okay, so substitute a number for each variable, trade it, perform the operations, and simplify. So let's do example 1 together. Ready? Any questions about what an expression is? Any questions about what evaluate an expression means? Sure? Okay, here we go. So below that, write example 1. This says evaluate, which we hopefully we know what that means now. Evaluate the expression when Christian n equals what? Oh, I was just seeing if you're following along. I'm just getting it right out of the book here. 3. Okay. Huh? I don't know, just to stimulate some conversation so I'm not the only one up here talking. Sorry, alright, fine. Alright. Okay. I just thought you liked to talk. Okay. Evaluate the expression when n equals 3. Now remember, evaluate means trade the number for the letter. So what they're saying is trade, whenever you see an n, which is a variable, trade the n out, and in its place put the number 3. Okay? 3's on the sideline, n's in the game. The coach says, n, come out, 3, go in. Okay? So, A, the expression is 13 times n. So the first part is to do the substitution, right? So we're going to rewrite that as, instead of 13 times n, 13 times 3. Okay? That's substitute this and this, right? That's the substitute, and now the next part of it was substitute, perform, and then perform the operations. What's the operation here? Anybody? Multiplication. So you got to do 13 times 3. Okay? Now, I know you guys have trouble with this sometimes. One way to do this is you could write it like this, right? It's 39, good. 3 times 3 is 9. 3 times 10 is, or 1 is 3, right? So this is 39. Let me just, this is just kind of a math skill that is going to be helpful for you. Another way to do 13 times 3, right, is to think of the 13 as a 10 and a 3. That's what 13 is. So it's easier to do 3 times 10, right? 30. And it's easier to do 3 times 3, which is 9. So break this into 10 and 3. 3 times 10 plus 3 times 3. Does anybody do that? Like some kids just naturally do that in their head. I'll give you, here, you don't have to write this one down. I'll give you another one, see if you can do it in your head, okay? This is not from the book. You don't have to write this down. Let's just try, like, I don't know, 42 times 5. So take the 42, right? 42 is 40 plus 2, isn't it? This is a 40 and a 2. So do 5 times 40 and 5 times 2. And add that together. 210. See? 42 is a 40 plus a 2, right? So then you do 5 times 4, 40 is 200. Right? 5 times 40 is 200. 5 times 2 is 10. 200 plus 10 is 210. Here, I'll give you an easier one. 35 times 3. That's 30 plus 5, right? 105, good, yeah. It's good. Did you do that in your head? No. Still good. 35 is 30 plus a 5, right? So these are easier to do. 3 times 30, can you do that in your head? 90. So 3 times 30 is 90. 3 times 5 is 15. And you just have to be able to add 90 and 15. 90 plus 15 is 105. What, like, just like this? Well, yeah, but this way, if you want to do it in your head, this is like just a math technique. All right. Back to the example one. All right, letter B. 9 over n. Now again, we're evaluating when n is 3. So what's the first thing we have to do? Do substitute first, right? So this is 9 divided by 3, right? See, the n is a 3. Now, 9 over 3 means what? What's the operation? Division, right. This means 9 divided by 3, which is 3. Okay, n minus 1. What's the n? 3. So we're going to write 3 minus 1, which is 2. D. N plus 8. We're going to substitute out the n. And 3, right? 3 plus 8. Good. And then do the operation, and you get 11. Right? So any questions about evaluating algebraic expressions? It's substitute and then do the operations. It's basically what it is. Okay? All right. Do you see those 4 problems at the bottom that say guided practice?
Yes.
I want you to do those 4 and then I'll give you the answer. You can see if you got them right, okay? I'll give you like 2 or 3 minutes to finish those. Yeah. So below this, right, guided practice. 1, 6y, 2, 8 over y, 3, y plus 4, and 4, 11 minus. These all are y equals 2. All right, Elizabeth, what'd you get for number 1? Oh yeah. Melvin, what'd you get for number 1? Huh?
You said 12.
Okay. Yeah, 12. 6 times y is 2, which makes 12. All right. Gabriel, what'd you get for number 2?
4.
4, good. 8 over 2. 8 divided by 2 is 4. On, what'd you get for 3? 6, good. 2 plus 4, 6. Questions yet? All right, last one, number 4. Derek, what'd you get for 4? 9? You sure? Yeah, it's 9. Good. 11 minus y is 2. 9. Okay, any questions? No? Okay, let's do example 2. Sorry if this is slow, but this is lesson 1.1. Christian did warn you yesterday. Huh? Remember yesterday you were telling us how easy 1.1 would be? All right. So example 2, this is going to be a word problem. And this says, evaluate an expression in 2 variables. Well, what does that mean? Anybody? If there's 2 variables.
It's 2, 5, like 2 of the
Yeah, 2 different letters. Like an A and a B, or an X and a Y, or a C and an F, or something, right? So 2 different letters, and you have to substitute in 2 different numbers, right? Like if this was a team, that's like 2 players come out, and 2 different players come in, okay? It's not a 1-for-1 trade, it's 2 for 2, okay? All right, so example 2. I'm going to read this. You can read it to yourself. Movies. The total cost of seeing a movie at a theater can be represented by the expression A plus R. That is the total cost, is A plus R. Where A is the cost in dollars of admission. Okay? A, yes. And R is the cost of what? What's R represent? The cost of the...
Tickets?
Well, that if it was tickets, they would probably put a T. And the A is the tickets, really. The cost of admission. That's that's your ticket. What else do you spend money on at the movie theater sometimes? Yeah, the R stands for refreshments, right? Because it's R. Okay. Cost of admission is A, cost of refreshments is R. Now the reason why they use variables A and R because we don't necessarily know how much it costs for admission, and we don't necessarily know how much it costs for the refreshments. Suppose you pay $7.50 for admission. So you pay $7.50 for admission. And $7.25 for refreshments. Find the total cost. So total cost is, what am I going to put here? What am I going to substitute in for A? Good, yeah. I'm going to take A out and put 750 in its place, right? Because it tells me A is 750. So 750 plus, what am I going to substitute in for the R? Remember, it's a letter comes out, a number goes in. 725, that's the refreshments, right? So the total cost here is 750 plus 725. So we did the substituting, now we have to do the operation, exactly. Which is what? $14.25. 25? 75. Good job. Okay. So this is a pretty simple question, but it's sort of getting you to understand what evaluate expressions means. What we did is we took the A and the R out, and in their place we put 750 and 725, and then we added. Any questions? Sure? Okay, we're probably halfway done. Ready? Below that, I want you to write expressions using exponents. So an exponent, this is like it's like another operation. Some of you already know what these are, I think. You don't have to write exactly what it says in the book. You can write it like this, all right? Just write down 3 to the 4th power. Now, this one, this is kind of more complicated. It's not adding, subtracting, multiplying, or dividing, right? It's something else. It's got this little tiny number up above. So what does that mean exactly is the point of this. What, Christian? Yeah, the n times n, yeah, exactly. Okay, so what I want you to realize is, the first thing is this. The little tiny number up there is called the exponent, or also sometimes referred to as the power. What's the big number called? Yeah, good, the base. Okay, so when you see this, you see like a big number and a little tiny number up above it. That's a power question or exponent question. The big number is the base, and the little number is the exponent. Okay? What does that mean? It means multiply the base by itself 4 times, because the exponent is 4. So 3 to the 4th means multiply 3 times 3 times 3 times... What? Is that enough 3s?
Yeah, no.
Now, how many 3s do I need? You need 4 threes because the exponent's 4. The exponent tells you how many of the base you need. So you write out the base that many times, and you need to put multiplication in between them all. Okay? 4 threes multiplied together. So you guys know how to multiply 4 numbers together? Christian?
Put a little thingy, like, put a little triangle thingy under, like.
Oh yeah, okay. Like basically, you just multiply 2 at a time, right? Yeah. Like do 3 times 3 makes 9. Then you do 9 times 3 is 27. 27 times 3 is 81. So that's it. 81. You could do this too. Look, 3 times 3 is 9. Times 3 times 3 is 9. 9 times 9 is 81. All right. So that's what an exponent is. Any questions yet? You sure? Okay. Example 3. Read and write powers. A. 7 to the first power. You don't need to write it out as words, but what we should do, this one's so simple it might be sort of confusing. 7 to the first power means how many 7s? 1 7. So all this is just 7. There isn't any more 7s to write. 7 to the first power is 7. Anything to the first power is just the thing, yeah, itself. Okay, B, 5 to the second power means how many 5s? Yeah, 2 5s. So a 5 and a 5. Does it mean 55? Yeah, 25. Does it mean 5 plus 5? No, 5 times 5. So when we're dealing with powers, it's always multiplication. 2 5s multiplied together. Alasia is 25. Awesome. Good job. Okay. 1/2 to the third power. What's the base? 1/2 is the base. What's being raised to the third power? It's the 1/2, right? So the 1/2 is the base. How many 1/2s do we have? 3 1/2. So we have a half, a half, and a half. And when we do the powers, what operation goes between the times, right? You guys know how to multiply a fraction? That would be adding.
Isn't it just like 2, 2, 2,
Yeah.
6, and then 1, 1, 1?
It's just straight across. Just 1 times 1 is 1, times 1 is 1. 2 times 2 is 4, times 2 is 8. Right? 2 times 2 is 4, times 2 is 8. Okay, D. Z with a little 5. That means, you say this? Okay, that's not right. 5z means 5 times z, right? That actually means this. Z plus z plus z plus z plus z. 5 z's added together. Is that what z to the 5th is? No, when we do these powers, the operation is always not adding, multiplication. Z to the 5th is not 5z. 5z is adding 5z's together. Z to the 5th is 5z's, but they're not added together. They are multiplied. That's it. You can't actually do anything else to that. So, okay. Okay, you see where we're at in the book here, everybody? We just did example 3. Okay, I'm going to give you a second to do those guided practice 5 through 8. So this is your independent practice for a second, for a minute here. Try to do 5 through 8, and then I'll give you the answers. See if you got it, okay? So below this, right? Guided practice. 5, 6, 7, 8. Five's a little confusing. Just try to realize about 5, there's no refreshments on 5, okay? When you read 5, there's no drinks. For people that are stuck on 5, can anybody tell me what the algebraic expression is? 5? What's the algebraic expression? No. Remember, the expression is like a number and a variable in an operation. What's the expression? The expression is what it looks like before you substitute the number in. What's the expression? It says it in the question there. 2a, yeah. And what's the a? What are we going to what number are we going to substitute in for the a?
475.
Yeah, 475. Good. So you have 2 times 475. Hey. Josh Gonzalez. I'm sorry, I'm not. Okay. Two times 475. Who got that? Yeah, it's 950. Good. You could look. You could do this. Look, 475 is $4.75, right? So do 2 times $4, which is $8. Okay, 8. 2 times 75 is 75 and 75 together make $1.50. So $8 plus $1.50 is $9.50. All right, Michael, what'd you write for 6? 9 to the 5th. Yes. Good. It's 5 9s multiplied, right? Angelique, what about 7? Yeah, how many 2s? Good, 8 2s. 1, 2, 3, 4, 5, 6, 7, 8. Right? Jacqueline, what about 8?
4 times 4 times 4. I mean, n times n times n times n.
Yeah. 4 n's. Any questions? Okay. Example 4. We're so close. Evaluate, which we know what that means, right? Substitute in and do the operation. Powers. So now we're going to evaluate questions that have powers in them, expressions that have powers. A is x to the 4th when x equals 2. So since we're evaluating, the first thing is the substitution part. So it's 2 to the 4th. Good. We're substituting the x was in the game, and the x now comes out. And what goes in the place of the x? The 2. Okay? So that's the substitution part. Now we got to do the operation. You might want to rewrite this as 2 times 2 times 2 times 2, right? What does that make? It's 16. 4 2's multiplied is 16. Okay, B. N to the 3rd when n is 1.5. Oh, yikes. Yep, this is 1.5 to the 3rd power, right? That's the substituting part, which is 1.5 times 1.5 times 1.5. How do we do that? How do we multiply these two? Anybody know? Like this. So if you have to multiply two decimals together, write them like that on top of each other, and then basically just multiply the numbers together first, but ignore the decimals at first. So just sort of multiply 15 times 15, right? 25, 5, 6, 7, 0, 5, 1. 225. That's 225 is 15 times 15, and then to account for the decimals, you say, well, this one here, the decimal's a 1 away from the edge, and this one's 1 away from the edge. So 1 here and 1 here makes a total of 2 decimal spaces if you move this back. So, yeah, good. So it was here. Now it moves 1, 2. So 1.5 times 1.5 is 2.25. That's this. To multiply that by 1.5 now, the third one, like this. So this one, just ignore the decimals, just multiply 225 times 15, and then when you get that answer, move the decimal back how many spaces? 3. See? 1, 2 for this one, right? And 1 for this one. Total of 2 and 1 is 3, right? So 5 times 5 is 25, 10, 12, 10, 11, 0, 5, 2, 2. 3375, where's the decimal go? Between the two threes, good. See, it was here, go 1, 2, 3 decimal spot. Okay? Okay, we're almost done. There's 3 guided practice. I'll give you a second. Try to do 9, 10, and 11. And I'll give you the answers. This one you write it as 8 to the 3rd. If you're stuck on that, right? Which is 8 times 8 times 8. which is 64 times 8, right? How do you do that? You could break up the 64 and do a 60 and a 4. 8 times 60 plus 8 times 4, or this. $32. 512? Oh. Yeah. Okay, this one is substitute in, you get 2.5 to the second power, which is 2.5 times 2.5. How do we do 2.5 times 2.5? Okay. You move it over 2 times at the end, yeah. But basically you just do 25 times 25, and then move the decimal 2 spaces at the end. Yeah. $625 is 25 times 25. That's right here. 1, 2. 6.25. Anybody get that right? Before I did? 2 people? Oh, good. 3? Okay. This is 1 over 3 to the power of 4, right? That's 1/3 times 1/3 times 1/3 times 1/3. It's this. Right? Okay. Multiplying fractions, it's easier than adding. You don't have to have a common denominator or anything. You just multiply the tops, multiply the bottoms, right? 1 times 1 times 1 times 1 is 1. 3 times 3 makes 9. 9 times 3 is 27. 27 times 3?
81.
81. Good. Anybody get that one right? 1 over 81. Well, congratulations, Joy. Sorry. Okay. Ready? Below this, there's one last thing we have to know, right? Area and volume. What? This is the one right before example 5, yeah. Okay, area and volume. Area is 2-dimensional, like this. Volume is 3-dimensional, like this. Okay? Volume is 3-dimensional, meaning like it looks like it could be coming off the page. Area, this regular square, is 2-dimensional, meaning it's like flat on paper. All right. We find the area of these by doing side times side. Area is S times S. Or you could write that as S squared. It's only 2 S's, right? So if you have a square and you have to find the area, you do one side times the other side. And that'll tell you the area. For example, if this side was a 4 and this side was a 4, the area would be, or 16, right? Yeah, 4 to the second. Okay, volume, it's real similar, but since there's 3 dimensions, there's 3 numbers to multiply. It's this side, the front width, this side, the depth, and then this side, the height. So volume is going to have 3 numbers. Volume is S times S times S. S to the third. just an example, if these S's were 4s, if this was a 4 by 4 by 4, what would be the volume? What do we do to these 3 4s? Just as an example. That would be 4 times 4 times 4, 64. All right, so you got this formula here for area and this formula for volume. All right? When you do the exercises on your own, you want to like have this handy because you'll see questions like this, and if you forget things, you look back at this. Okay. Okay. Last example. Each edge of a medium-sized pop-up storage cube shown is 14 inches long. The storage cube is made so that it can be folded flat when not in use. Find the volume of the storage cube. So they're saying there's this cube, and the edges are 14s. What's the volume? 14 times 14 times 14. Right? Which is 2,744. And you would write that as inches cubed. Okay, we're not going to do the last guided practice. That is it. But let me just talk about a few things here. 1 second.